We physicists have waited for 100 years, beginning around 1916, for this photograph. It is a nearby black hole, which might just be one of the most charming and puzzling characteristics in the universe. They are tremendous beasts concerning gravity, but simultaneously, for all intents and purposes, intangible to us. A black hole weighing perhaps 2 to 4 million times the mass of the Sun. Anyway, considering the investigation that was placed into them over the last 20 or 30 years, we've gone from knowing, in a real sense, nothing about them to getting to figure out progressively more exceptionally close. Also, things have recently gotten more crazy. Michio Kaku recently detailed that we at last got a look at what's inside a black hole, and this new information sheds light on the nuances the world of science could have missed from the beginning. Go along with us as we dig further into black holes and reveal what's inside. Space is tremendous and dreadful. What are black holes? Before we get into the nuance of what Michio Kaku found, we have to talk about the basics. Although the vast majority of us have some idea of what black holes are, there are still a couple of gaps in the right information. You see, in 1916, Albert Einstein published his theory of general relativity, which predicted the existence of black holes. Around that time, the idea of black holes was totally theoretical. It required an extra 50 years for established researchers to find evidence that black holes, in fact, exist. This happened during the 1960s when they were studying the star X1, a magnificent body, and saw an oddly bright blue star that was emitting X-rays. This star was certainly not a lifeless object, but was orbiting a giant black something. Upon further assessment, it was seen that the X-rays weren't simply moving around on their own. They were being sucked into the black thing they were orbiting. Thus, the name black hole. This discovery was enormous since it gave proof that black holes truly exist, and they weren't just an invention of Albert Einstein's wild imagination. While that was incredible, it also meant that there was this fascinating substance in space that we urgently needed to learn more about. So, scientists from one side of the planet to the next got to work. This black hole was named Cygnus X1, and it is situated in the constellation of Cygnus, about 6,000 light-years from Earth. It was no small discovery. It's many times brighter than the Sun and, of course, incredibly dense, which gives it a strong gravitational pull. The gravitational pull is so strong that not even light can escape it. For this reason, it is known as a black hole. The concept of a black hole is both charming and startling. It is a region of space where gravity is so strong that nothing, not even light, can escape. Anything that gets too close to a black hole will be pulled into it, gone forever. However, that piece of danger makes it even more important to learn everything there is to know about them. Was this it, or were we just beginning? The answer turned out to be the latter. After the discovery of Cygnus X1, scientists began to search for other black holes. They found that there may be almost 100 million black holes in the Milky Way alone. However, since they are so incredibly difficult to identify, we still don't have an exact number. Apparently, there are a few million black holes in the Milky Way, in our own galaxy, which makes them even more important to study. So, let's break it down. The main thing with black holes is always going to be gravity. Their gravitational pull is so extraordinary that anything that enters it gets crushed down immensely until it becomes a singularity. In simpler terms, black holes are like massive vacuum cleaners that suck everything in. One of the scariest parts about studying black holes is the fact that if someone were to fall into one, they would reach a point where they become a singular line. This process would occur slowly, and the individual would die before the true breakdown of reality occurs. So, let's just say that no one should step into one. But they're all over. So, could we be in danger? Despite the fact that the closest black hole to Earth is nearly 500 light-years away, it's still close enough to raise many concerns. In 2021, researchers were able to produce the first clear photograph of a black hole, the M87 black hole. This black hole was captured over several nights, and with every photograph, the researchers gathered more and more evidence about it. They had to line up the individual photographs to fill in all the gaps, and in doing so, they were able to confirm that there are 3 layers to a black hole. It's not just one single expanding hole of nothingness, as many people believe. Things are much more complicated than that. To even get to the nothingness part of a black hole, you have to survive the first 2 layers. The first layer is known as the event horizon. Within the first layer is the final boundary. Once you pass the event horizon, moving forward is your only real option, and you will be sucked into the black hole. But the 3 layers just get worse from there. The second layer is the photon sphere, where light orbits the black hole. Any light that enters this region will be captured and can't escape because of the black hole's gravitational force. Finally, we come to the third layer, the singularity. This is where everything that enters the black hole is compressed down enormously until it turns into a singularity. The singularity is a point in space-time where the laws of physics, as we know them, break down, and we can't predict what happens next. Now, what makes all of this even worse is the fact that each black hole you study will be completely different from the last. Sure, they tend to follow the same 3-layer pattern, but the way they function could be vastly different. As it stands, if this were anything else, all we would need to do is bounce back on those telescopes and just review the basics in detail. But with black holes, you can't actually do that. Scientists can study black holes indirectly by observing the radiation they emit and the gas and dust that surrounds them. Sending a probe into a black hole is impossible because anything that enters the event horizon is pulled straight into the singularity, where it is crushed into an infinitesimally small point. So, you can't exactly waste billions of dollars just to get a glimpse, because the second the probe gets close enough, it will be sucked into nothingness. Because of that obvious problem, scientists are left with no choice but to study these objects in a 2-dimensional manner, even though they are 3-dimensional singularities as a rule. To make matters even more challenging, there are also the 2 issues of each black hole being unique and the laws of physics, as we know them, breaking down when we attempt to study the interior of black holes. Conventional methods of scientific inquiry don't really apply to the study of black holes. That doesn't mean scientists haven't been busy. There are lots of different theories and explanations for black holes, and with each one, things get more and more fascinating. Are you fascinated by the mysteries of space, black holes, and the secrets of the universe? If so, you're in the right place. By subscribing to our channel, you'll join a community of curious minds eager to explore cutting-edge discoveries and unravel the wonders of science. Don't miss out on our deep dives into fascinating topics, mind-blowing theories, and the latest breakthroughs in astronomy and physics. Hit that subscribe button and turn on notifications to stay updated with all our exciting content. Let's uncover the mysteries of the cosmos together.